Hello, everyone. My name is Xiang, and I'll be introducing the joint work with Ning, Bradley Hauer, Greg Kondrak, bridging the gap between BabelNet and HowNet, unsupervised sense alignment and Sememe prediction. A knowledge base is a centralized repository of information and knowledge that is used to store, organize, and retrieve information. It is designed to make it easy for people to find and use information they need to perform their job and complete the task. One of the most important type of information in NLP is sense information, which is defined and stored in sense knowledge base, known as sense inventory. BabelNet and HowNet are most frequently used sense inventory for English. BabelNet defines senses by synonyms and describe them using a manually crafted glosses. Specifically, all synonyms and translations in different languages are grouped into the concept called synset. For example, synset for two separated senses of word bank contain different Chinese and English synonyms, with a gloss for each synset, which can be seen at the bottom here. However, during our experiments and analysis, we found that BabelNet has a relatively poor coverage for Chinese words and not the most suitable sense inventory for Chinese. Instead of using BabelNet, Chinese NLP community has been using another knowledge base called HowNet for most of the Chinese tasks. HowNet is deemed as a bilingual sense inventory with a coverage of more than 100,000 Chinese words and close to 90,000 English words. Different from gloss-based sense inventory, HowNet associates each senses with a set of sememes, the minimum semantic units in natural language. In addition, HowNet annotates each sense and sememe with English translation. For example, the two senses of bank contains different sememes. One contains land, be near, waters, and another contains institute, finance, and money. Each sememe and sense here all appear in Chinese and English translation pairs. Notice that some of the English translation and Chinese translation have more than one word. Sememes play a very important role in lots of NLP applications. Compared to gloss-based knowledge base, sememes are just a set of words and can be easily encoded using word embeddings and parsed by computer using graph. Therefore, its application spans a wide range of NLP subfields, including word sense disambiguation, representation learning, language modeling, text matching, and so on. We see an increasing trend of usage of sememes in Chinese NLP field, owing to the open source sememe knowledge base OpenHowNet. Moreover, sememe is an approximate realization of semantic primitives, which states that there is a set of universal basic concepts that can be used to convey the meaning of any linguistic expressions. Although sememe provides a way of representing concepts, their incorporation into natural language processing tasks has been limited by the lack of available sememes resources for commonly used available inventories. The only large-scale sememe knowledge base, HowNet, is limited to only two languages, English and Chinese. Previous work on automatically predicting sememes for BabelNet concept has depended on large human label data. Not only did they perform poorly in predicting sememes for sense in their language, they also lack explainability since such predictions are based on neural network. This makes it harder for the downstream task that tries to utilize sememe information, since we often cannot locate the source of the error. A related problem is aligning lexical knowledge base, which consists of associating entries in one resource with another one. For example, BabelNet was created by associating Wikipedia articles with WordNet senses. In this work, rather than attempting to predict sememes directly, as in the prior work, we instead attempt to align BabelNet concept and the HowNet senses. Since each HowNet senses is annotated with sememes, correctly mapping the BabelNet concept to a HowNet sense will effectively add sememe information to the corresponding BabelNet synset, as well as associates a HowNet sense with information unique to BabelNet, such as synonyms information. We propose a fully unsupervised algorithm which achieves reliable and stable results and produce fully explainable mapping. The ability to identify precisely why particular sememe was associated with a concept is a unique strength of our method, which we believe will facilitate the analysis and development in the downstream test. So our method has 4 stages, each relaxing some constraints until alignment is found, as shown in the graph here. Our first stage uses a strict criteria for aligning BabelNet synset to a HowNet sense, which is aimed at a high precision rather than high coverage. Later on, the stages will aim at improving the coverage. It exploits the fact that each HowNet sense is annotated with a lexicalization in both Chinese and English, as well as a well-known observation that distinct senses of words may translate differently. For each Chinese-English pair in BabelNet, we check if there is a HowNet sense which has a Chinese localization and English localization pair has the exact same pair as the pair in the BabelNet. If there is, we add that sense to the aligned sense. Once this stage is completed, if a line set is non-empty, we return it as a set of senses aligned. Otherwise, we continue to the next stage. Second stage relaxes such an exact matching to an n-gram partial match. So every Chinese word consists of 1 to 4 characters. Unlike English words, each individual character has some meaning associated with it. Therefore, words that share 1 or more character often share part of their meanings, as shown in the graph here. The exact match will miss some semantic correlation between such words, which reduce the coverage of the mapping. We therefore propose the approach shown in the graph, where we align each Chinese words and English words with the partial characters that are the same with each other. So we first look at a sense which contains the exact English words as the English words in the BabelNet synset. And then we further compare the Chinese word in the translation pair by reducing the k grams to find a match. If such a sense is found, we add it to our results. If not, we instead look for the senses have the k-2 grams, which is in common with the Chinese words that in the BabelNet synset. This partial match approach is explainable, unsupervised, and also efficient. Stage 1 and 2 are sufficient to find at least 1 HowNet sense for roughly 80% of the synset. Stage 3 attempt to map the remaining synsets by exploiting 2 key properties. First, many words are monosemies in HowNet. And second, sememes are represented as words, which can often be found among the hypernyms of a given BabelNet synset. If a BabelNet synset contains any Chinese or English words that have only one sense in HowNet, such as ultraviolet, then we assume such a sense of that word must align to the only sense in HowNet. Monosynonyms words tend to be less frequent in text, but it makes up a substantial proportion of the words in HowNet. We found that those BabelNet synsets that could not be aligned with at least 1 HowNet synset by any of the first 3 methods were generally proper nouns, which is a specific terminology for a place, a person's name, and so on. We conduct our experiments. Since our proposed method is a first ever algorithm for aligning BabelNet and HowNet, there is no gold annotated dataset for this task that we can use as a test set. To the best of our knowledge, the only datasets that connects BabelNet and HowNet is Sememe datasets, which was constructed for the evaluation of Sememe prediction method. Therefore, we evaluate our sense alignment algorithm extrinsically on the task of Sememe prediction. So Sememe consists of 15,000 BabelNet synsets, each annotated with a set of HowNet Sememes, which comprise the meaning of the synsets. The Sememe sets were created manually by more than 100 bilinguals. Following previous work, we adopt the measurement, mean average position, MAP, and F1 score as our metrics. Our overall results outperform all prior work according to both metrics and established our method as a new state-of-the-art for Sememe prediction. In particular, the improvement on overall F1 score is 12% over the previous supervised state-of-the-art method, which was designed specifically for this task. In conclusion, we present a novel unsupervised method for aligning BabelNet and HowNet, and we achieved the state-of-the-art results on Sememe prediction, and the result of which outperforms the supervised method to a great extent. And our future work includes leveraging such a sense alignment information for other semantic tasks.